Mrs. Hauser here with your third lesson of Unit 1, Distance. What do you need to know from this lesson? How to apply the Pythagorean theorem and how to find the distance between 2 points. So what is that Pythagorean theorem? Pythagorean theorem is a squared plus b squared equals c squared. And we have a special part of it, c. It gets to be all by itself because it's special. Why is it special? It's the only side in the right triangle that does not touch the right angle. It's across from it. We call it the hypotenuse. Something else to note here is that A and B can be either of your legs. So we have A and B, and it doesn't matter which leg I give which value. So let's apply it. Let's find the missing side. I always start when I see a right triangle and 2 side lengths by writing out a squared plus b squared equals c squared. And then I always identify the hypotenuse of my triangle. I don't have anything to substitute in for c, but I do for a and b. So I get 7 squared plus 2 squared is equal to c squared. I know that 7 squared is equal to 49, and 2 squared is equal to 4, and that will be equal to c squared. 49 and 4 together is 53. And now I have c squared, but I want c. So what I'll do is I will undo that squaring by taking the square root of each side. The square root is the inverse operation of squaring, and I'll get 7.28 equals c, or c is equal to 7.28. So my answer to that missing side length would be 7.28 inches, because I don't want to forget the units that they gave. So now let's look at one that's slightly different. Again, I have 2 sides of a right triangle, so I'm going to go ahead and write out that Pythagorean theorem. And again, I'm going to identify my hypotenuse. And this time I have something to substitute in. I'm going to label each of my legs, one with A and one with B, and I'll substitute into that Pythagorean theorem. So a squared will be 6 squared plus b squared, because I don't have a value to substitute in, is equal to 8 squared. 6 squared is 36 plus b squared is equal to 64. And now I need to get b squared by itself. I need to isolate it. So I will subtract 36 from each side, and I'll get that b squared is equal to 18. Not 18, sorry, 28. And then I'll go ahead and take the square root of each side. B is equal to the square root of 28, which is 5.29. So B is equal to 5.29. And again, I don't want to lose the unit, so I'll put 5.29 inches, and that's the answer to that problem. So now let's apply that. I want to find the distance between 2 points. There's 2 ways I can do this. I can use the distance formula, and I can also use the Pythagorean theorem. The distance formula is actually an application of the Pythagorean theorem. So what I'm going to do is use the distance formula first, and then I'll use the Pythagorean theorem. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, square root of the whole thing. When I'm working with distance or any coordinates like this, I like to go ahead and label my points to make it easier to substitute in. And now I'll go ahead and substitute in to that distance formula, I need to take my x2, which is -2, minus my x1, which is 4. I'll add that to my y2, which is 6, minus my y1, which is -3, and I'll square it. I'll get that distance is equal to the square root of -6 squared plus 9 squared. Remember that when I subtract a negative, it is like adding. Then I'll get that distance is equal to the square root of -6 squared is +36. Negative times a negative is a positive. And 9 squared is 81. And then I'll get that distance is equal to the square root of 117. Square root of 117 is 10.82. Okay, so now let's try it using the Pythagorean theorem. I'm going to graph those points for -3 and -2, 6. I'll graph the line that goes between them. Then I'm going to turn it into a right triangle. I'm going to count my boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. And I know that this is my right angle because this has an undefined slope and this has a 0 slope, and those are negative reciprocals of each other, so therefore these lines are perpendicular. So I know that line segment that would be the hypotenuse is the line segment I'm trying to find the distance of. So now I'm going to go ahead and use my Pythagorean theorem. A squared plus b squared equals c squared. 9 squared plus 6 squared equals c squared. I'll get 81 plus 36 equals c squared. And 117 would be equal to c squared. I would then take my square root of each side and get 10.82 equals c, and I can use that symmetric property once more to write 10.82 as my answer. So that would be the distance of that line segment. Notice I get the same answer. It's totally acceptable to do it either way. One short note, I just want to talk about the distance between 2 points that run across the same line. If you substitute this into the distance formula, it's going to come out really cleanly and you'll get directly to your answer. So x2 minus x1 squared plus y2 minus y1 squared. I'll go ahead and take the square root of that. I like to label my points again. So I will do -2 minus -2 squared, because those are my x values, and 6 minus -3 squared, because those are my y values. I'll take the square root of all of that. I remember that subtracting a negative is like adding a positive. So I'll get 0 squared plus 9 squared. Distance is equal to 0 plus 81, the square root of that. So the square root of 81, or 9. But what I think is even easier is to say I have -2, -3, and -2, 6. And if I come along here, because this lines up perfectly, I can just count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So either way is acceptable. Graphing it is a little bit easier. All right, that's it for distance. If you have any questions, come see me.